we're doing in example 2 is we're finding the magnitude of a vector. So we talked about the magnitude of a vector in the introduction video, the first video you guys should have watched today. The magnitude of the vector is the actual distance or length of the vector. So remember, every vector has a direction and a magnitude. So the magnitude sometimes will be called the absolute value of the vector. The reason for that is we think of vector with the magnitude, a distance of the vector. We know that distance can't be negative. It doesn't matter what direction my vector would be going on the coordinate plane. Our distance is going to have to be a positive value. So hence the absolute value. So we're going to denote the magnitude of a vector with an absolute value brace. Now, some textbooks or sometimes online, they'll use double braces on the side. We're not going to use that. We're just going to use a simple absolute value sign to denote our magnitude. So when we're trying to find the magnitude of a vector, there's two formulas we have to be aware of. This is going to be the formula for a vector not in standard position. This will be the formula for a vector in standard position. So let's first talk about the formula for a vector that's not in standard position. We are using the distance formula to find this. You learned the distance formula the first time in, I think it was probably geometry. We have x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root. These are the ordered pairs of 2 points in the coordinate plane. So the formula for standard position, we don't have x1 or y1 because the tail of a standard position vector is 0, 0. So there's no sense in doing minus 0, minus 0. So all we're going to have there is a squared plus b squared. So a, if you remember from the first video, that's the head of the vector. It kind of represents the same thing as x2. So if we did x2 minus 0, get rid of the 0, you end up with just x2 squared. So that's why we just have a squared. A is representing x2, the head of the vector. Same thing with the b's. We're not going to subtract 0. There's no point to it. So y2 is going to represent b here, and we end up with y squared. So two formulas. And if you don't like the fact that there's two formulas, you can always use this for a vector in standard position and just write out minus 0, minus 0. So this one will work all the time. This one is just a separate formula for standard position if you want to kind of jump and skip that minus 0 part. So in example 2, what we have is 2 points, P and Q. They have P at -3, 4. They have Q at -5, 2. And they want us to find the magnitude of the vector between those 2 points. So we think of this magnitude of vector PQ. That's how I'll write it. That's equal to the square root of x2, -5, minus x1, -3, plus, squared, plus y2, which is 2, minus y1, which is 4, squared, and we will simplify. So what we get, -5 minus -3, that's -5 plus 3. -5 plus 3 is -2. So we have -2 squared plus 2 minus 4, which is -2 squared. So we have -2 squared plus -2 squared, and we end up with 4 plus 4, which is the square root of 8. So this is, again, the magnitude of PQ. Now, your book's going to want you to break that radical down, so we can go back to dating game here. 8 breaks into 4 and 2. 4 is 2 and 2. There's your date. So a 2 will come out. 1, 2 didn't have a date, so he stays in. So we have magnitude of PQ is 2 radical 2.